Hi, everybody. I'm Greg Fishel. Welcome to bonus weather video number 2 for this week. And we're going to talk about why is severe weather season primarily in the spring. It's not exclusive to the spring. We certainly found that out in November of 1988 in Raleigh when we had a very strong tornado in the wee hours of the morning go through North Raleigh. But in general, the peak of the season is in the spring. And so we want to try to address the question as to why that is. So let's get on with it here. It all has to do with lapse rates and also wind shear. So this is how the temperatures change at RDU, or approximately RDU. The closest upper air station to us is Greensboro. And so I took the 30-year average 500 millibar temperature at Greensboro and the normal high temperature at Raleigh. Now, the one thing that you may notice here is that and by the way, that is correct, at 18,000 feet, the average temperature at 500 millibars in January is 0, okay? And one of the things I always like to tell kids when I went to visit schools back in the day is that, do you know that 6 miles from your house it's below 0 every day? And they say, really? What town is that? And I said, it's not a town, it's straight up, okay? So the 500 millibar temperature does get just down to 0 or slightly below on average. There are days that it gets colder than that. But notice the distance here, and I'm going to try to illustrate this. The distance between the normal high and the average 500 millibar temperature begins to increase as we head through the spring because the normal high at the surface is increasing at a quicker rate than the 500 millibar temperature. In fact, it's actually slightly colder at 500 millibars in March than it is in January. So the difference in temperature from the ground up to 18,000 feet is increasing with time, and it actually peaks here in the summer months, which gives you a pretty good idea as to why we get so many thunderstorms here during the summer. But the one thing that really, I thought, sort of points this out is that look at the high temperature and the 500 millibar temperature, January 1st, February 1st, and so forth. Now, at Raleigh, at the RDU airport, in January, on January 1st, the normal high is 6 degrees colder than it is on December 1st, okay? Then it goes up 1 degree by February 1st, 6 degrees by March 1st, 9 degrees by April 1st, and so forth. And then once we get to August, then it levels off and starts to go back down. Now, the 500 millibar temperature decreases 4 degrees from December 1st to January 1st, drops another 2, only goes up 1, and goes up 3, and then 5, and so forth. So if you take a look at the rates of change and how they compare, this is what you end up getting. That the biggest change or biggest differences in the rate of change between 500 millibars and here at the ground are the months February, March, April, and May. So the lapse rates are increasing at the quickest rate during that particular period of time. Now, the lapse rates continue to increase, but just at a much slower pace after that point in time. So the atmosphere is destabilizing very, very quickly during the months of February, March, April, and May. And the other thing that is worth noting is that if you take a look at the normal highs at International Falls, Minnesota, and Brownsville, Texas, I sort of tried to pick, one of the farthest north points and the farthest south point. By the way, look at that. Can you imagine having a normal high of 16? I mean, our normal high is around 50 on January 1st, or low 50s, so that's a whole different world up there. Brownsville, Texas, the normal high January 1st is 72. So the difference between the two is 56, okay? But then look what happens to that difference as we head on through time. It drops to 41 by April, 30 by May, 23 by June, and in July and August, it's only an 18-degree difference between the normal high in International Falls and the normal high in Brownsville. So the upper-level winds are driven by temperature contrast, okay? So the more contrast you have, the stronger the upper-level winds are going to be. That creates more vertical wind shear. That tends to tilt the updraft of the thunderstorm. Instead of being straight up and down, it tilts. And so it's able to last longer that way because the rain is not falling down through the updraft. The updraft and the downdraft are remaining separate. I think we talked about that at some point in time. So the wind shear is a real critical thing. And so you can understand why the wind shear goes to pot in the summertime, because the difference in temperature from north to south across the United States is just not all that great. But during the time of year when it is very large, then that can make a big, big difference. And the thing about it is, if you look at the months of like March and April and May, the upper atmospheric temperatures up in southern Canada, northern U.S. are still pretty cold. And so if you start to get into one of these high amplitude patterns, where the jet stream is going like this, and you start to transport some of that cold air at 500 millibars deep into the southern U.S., and at the surface, the sun is very, very strong, and the normal high is going up like a house afire, then your lapse rate goes crazy. And so once you get into the summer months, the 500 millibar temperature isn't that cold up in Canada, and so it's not as big a deal. But you start to mix that cold air aloft, drive it south into the United States, where the surface temperatures are beginning to warm up quickly during the spring months, and you've got a big recipe for trouble. So that's basically, in a nutshell, why the spring season is the favored time for severe weather. Again, it's not exclusive to that, but it certainly is the favored time. That's when we see the most tornadoes and the most damaging winds across the United States. All right, I hope that made a little bit of sense. We'll have another bonus weather video for you coming up next Tuesday, and the daily update today is going to be very, very short because I've got a concert tonight, and I've got to be ready to leave here at 4:45, which is earlier than I normally have to duck out. So we'll just basically address the forecast for the next 7 days and leave it at that for now. All right, folks, have a wonderful Friday evening and a wonderful weekend, and we'll talk to you again soon. Take care.